Welcome to our cable modem termination system tutorial. In this brief tutorial, we will describe the three parts of a CMTS, describe the functions provided by a CMTS, discuss why CMTSs are often used to shape and limit upstream traffic in a cable network, and briefly describe the top three CMTS vendors. Before we get on to our CMTS topic, let's briefly describe some terminology we'll use throughout this tutorial. In a cable system, the downstream direction refers to data that originates at the cable head end and heads towards a subscriber. In comparison, the upstream direction refers to data originating in a subscriber and heading towards a cable head end central office. In a cable system, downstream data typically is broadcast to all subscribers. Header information in the packets allows the recipient to intercept the data while allowing all other recipients to ignore the packets meant for other subscribers. In this picture, we see house number 3 is accepting data from the cable head end while the other 3 houses are ignoring the data. In the upstream direction, things are inherently more complicated in a cable system. Because of cable's hybrid fiber coax systems deploy a branch and tree architecture, they inherently make information moving in the downstream direction much easier than in the upstream. Because this system was originally designed to carry massive amounts of video traffic towards the customer and only carry tiny amounts of information back towards the cable central office, MSOs have been forced to evolve these systems over time to increase the amount of upstream bandwidth available, as internet access and voice have been added to these networks. Now let's move on to our discussion of the CMTS. A CMTS consists of 3 parts: a router, a high-frequency radio front end, and a filter. Now let's see how these 3 pieces fit together. You can think of a CMTS as a router with an Ethernet interface on one end and an RF interface on the other. Both sides of this interface, the Ethernet interface and the RF interface, contain IP packets. On the Ethernet side, these IP packets typically ride on a layer 2 consisting of a coax-based Ethernet connection or a fiber-based SONET link. On the subscriber side, these IP packets are wrapped inside MPEG frames riding on an RF carrier. Now let's see how the CMTS sits in a cable network. The CMTS typically resides in a cable head end or a cable central office. Coax or fiber optic links coming from subscriber homes enter the cable modem termination system. In this picture, we see that a subscriber is connected to a cable modem and is taking both voice and internet data services from the cable MSO. The cable modem at the subscriber premises modulates this information and puts it onto the coax. The CMTS terminates the coax and demodulates the information. After passing through a filter, which we will describe briefly, it then enters a router and then routes the information to a much larger router, also typically co-located at the cable head end. This router then passes voice information onto a gateway, where it eventually terminates on the public telephone network, and data is passed along to the internet. Here's what it looks like when video is added. Although this picture is far more complicated than one previously, the only thing we're trying to show here is that a cable modem termination system typically does not process the video signals shown in blue, but instead only processes the data signals shown in red. Earlier, we said that information is much easier to send in the downstream direction in a cable system than in the upstream direction. The third function provided by our CMTS is a filter or traffic shaper. What this does is it inherently limits the amount of bandwidth available to each customer in the system, so that no one customer takes more than his fair share of the upstream bandwidth that is a precious commodity in a cable system. We'll have more to say about this upstream filtering when we discuss DOCSIS 3.0 in a separate tutorial. Finally, we see the three largest CMTS vendors. They are Aris, Cisco, and Motorola. Although all three boxes look alike, at any one time, any one of these companies may be a technology leapfrog ahead of the others. Now let's review what a CMTS does. At a subscriber home, information from the voice and data networks is modulated onto an RF carrier by a resident cable modem. Back in the central office, a CMTS terminates these cable modems, demodulates the signals, and feeds an Ethernet switch with both voice and data. A CMTS system typically does not process video signals. That concludes our brief tutorial on CMTS.